So there was this recent idea to repair damage to the brain or something and promote neurogenesis by putting chloroplasts into the brain of creatures. These chloroplasts produces oxygen locally at the lower and without flooding the body with too much oxygen, and beyond that produces sugar for power. However, I have a lot of problems with this study, and I'll put the link below to the video explaining it and to the actual study from a different site. The problem is that they did it first in tadpoles, and tadpoles can have much more of a regenerative ability than other things because you can cut off parts of the tadpole, and when they go through metamorphosis, they can regrow those parts. Their brains are surprisingly similar in many ways to human beings with like anesthetic and stuff, but that's anesthetics. Also, they lack a blood-brain barrier and all these sophisticated stuff that we have to filter out blood before it reaches the brain and filter out blood that's leaving the brain and promote a more homeostasis. They have a much simpler brain that might be more easily repairable. And we can go on and on with stuff like that. They also directly injected it, which in a small organism might be easier compared to injecting a bigger volume of the human brain, but it might also have a hard time reaching deep down and spreading out. And they also have to pump in light. This might be hard in a bigger brain to pump in light to power this whole thing. But I think the idea might be somewhat salvageable in a different format, because the idea of giving the brain more nutrients, pumping out bad stuff faster, and putting drugs in to promote healing might be an actual very, very good idea. I just don't think the way they did it is a very good way forward. So I don't want to sound too harsh or negative on their idea in many ways. But a quick little brain anatomy. The brain uses over 20% of the body's energy. If you want to repair it, it's going to be even more. However, when you use up a lot of energy, you also produce a lot of toxins. These toxins can hurt healing and promote inflammation, even be counteractive, and promote too much too fast. The brain also has something called the blood-brain barrier. The blood-brain barrier is a barrier between the blood in the rest of the body and the brain and spinal fluid that has multiple pieces. It's quite complex, but it helps keep you. It really is the reason why you don't always get sick. It doesn't always cause brain damage, but it really makes the blood composition slightly different for the brain, and a little bit for the spinal fluid, but also for the spine, but more so for the brain. A little bit more. It's a different sort. It also acts as a buffer, so body changes within inside your body don't change the brain blood as much. So, and it also keeps some stuff more inside the brain and pumps out stuff faster. Not only keeps stuff out, but I mean, giving drugs is really hard to the brain and all these other things. We can weaken the blood-brain barrier through certain chemicals and stuff, but they all had side effects. And if you weaken the blood-brain barrier, you make a person more susceptible to a wide range of diseases and problems because they don't have to filter as well. Conversely, we can make stuff pump out of the blood-brain barrier better, but then you lose more stuff too. And the blood-brain barrier can also has a problem that if there's something that's going wrong in the brain, it can keep it stuck in the brain more, so certain diseases when it is breached. So my rough idea, and this is a very rough idea, is why don't we develop an artificial kind of blood-brain barrier with its own pump, so we can increase the amount of blood going to the brain, so increase the amount of nutrients, but in the right format, and increase the amount pumping out, just to promote brain healing, or for people with certain brain disorders. It might help you with migraines, or migraines too, that have problems with blood flow to the brain, and a vast variety of other things. You could also have it that it oxygenates the blood extra amount before entering the brain, but in a much more controllable manner. And by controllably oxygenating the blood, you cannot overload the oxygen, because too much oxygen will damage the brain, prevent healing, but just the right amount, so it has the extra energy needed in a gentle way. And you can remove CO2 in the right amount. so that it doesn't have too much CO2 build up. Now it has to do is careful also to maintain the right pH, because CO2 and oxygen help control this pH in the blood, and pH can hurt the brain and cause seizures or migraines, conversely, and we have different sensors. Now, in a more sophisticated setup, you can also have it pump certain types of nutrients from the body more. So you can have it stimulate, you can have a stimulant that makes your body give off more sugar, then pump it into the brain more, or pump in more salt into the brain and stuff. You could even have a separate canister in the future with the nutrients for the brain, and that canister could contain sugars, it could contain certain salts and minerals your brains and electrolytes your brain might need that it's losing because it's more rapidly and stuff like that. It could contain hormones and stuff, and if it's a more complex proteins and stuff that your body needs, or it can contain like proteins and amino acids that are more specifically for building brain tissue, and help it and keep it more local so it doesn't flood the body as much, because if it's pumping in more oxygen to the rest of the body, it can also cause the rest of the body more damage if it doesn't need it, or proteins or anything, because that's just an excess for that part of the body. When if you do it more locally, it's better. You could even have it have many small tubes that go to different parts of the brain, so it's more local to parts of the brain. So you have all this stuff for transporting. Now, to make it more advanced, you could have genetically engineered microorganisms within this thing to help produce certain chemicals more often, or control the balance in a more adaptive way, or sensors that can cause miniature pumps that can pump out more stuff into local storage units and pump it out during certain events to give a more adaptive buffer. This we already have this throughout the whole body with our kidneys and stuff, where it's pumping in and stuff out. I'm saying more adaptive. Some of this would be easy, some of this would be comparatively easy. Nothing is super easy. Some of this will be very futuristic, but I'm just putting it all out there. Another thing you could do is control the opposite, how much stuff exits out. So you can actually, with this thing, filter out the blood more so the blood remains cleaner, which could help promote neurogenesis in a much more effective way. If the blood is cleaner and then your body has to devote less energy to cleaning up all these little toxins, and maybe you could prevent prions and stuff, or prions building up, which is what causes Alzheimer's stuff, and the longer they stay in your brain, the more damage they cause. So you could even maybe prevent Alzheimer's if people get it at a young age. Just, that's probably very futuristic and out there. But, or you can pump stuff back into the brain at higher speeds if you're losing more because your blood-brain barrier is leaky and leaking out stuff too fast. You could also, by pumping up stuff more, you maybe have to go to the bathroom less. Because sometimes when it's pumping out stuff too more, you have to actually go to the bathroom more. And the rest of your body feels sicker. Another thing is, this could be an excellent method to introduce drugs and stuff like that normally can't cross the blood-brain barrier as easily. It might help fight brain cancer more, because normal drugs can't cross the blood-brain barrier. It could also be used as a better monitor in the future, to monitor the actual brain, the total brain health and everything surrounding brain health in a much more direct method than having to take like shots and food samples every now and then for a procedure that will be more dangerous if you have to do it so often. Now, installing it will be more dangerous, but for more often doing it. Another more idea to make this whole thing practical and doable is to have nanoparticles or special particle cells, or like artificial cells, to carry the nutrients and dump it off depending on local location. So one idea is, for example, is this with oxygen. This can give you much more oxygen brain safely, is that we've made artificial blood that doesn't last very long. With PET, which is a type of plastic that's very safe, that's filled up with little air bubbles of almost pure oxygen that slowly release oxygen, depending on the environment, but release oxygen faster when the environment has low oxygen. This kind of acts like an artificial blood, but better at transporting oxygen except for it doesn't replenish its oxygen as well as real blood. But then you could put a lot more blood into the brain safely without causing the same oxidative damage. Conversely, we also have fluorofluorocarbons, and the oxide versions, which can transport oxygen more effectively than blood by hundreds of times and more safely. The problem is that they are too hydrophobic usually. We could combine both technologies to make even better artificial blood, because PET polymer is compatible with fluorofluorocarbons. So you can make a hybrid nanoparticle with both, and you can then make it not have the same bad hydrophobic properties. And you could replenish it, make it have more air by including this blood thing like an artificial lung or something like that even. This also could help with other body parts of healing, because if this is doing some of the work of the blood-brain barrier and stuff, then the bodies have potentially more energy and have less inflammation and stuff like that, so they can calm down. And also brain inflammation can affect the rest of the body, because some inflammation can leak out of the brain and cause immune system reactions in the rest of the body and damage the rest of the body. So it also would help in some ways indirectly help the healing of the rest of the body, or make it not as important. Another thing is you could have particles similar designed for dropping off sugar or something like that, or it's quite easy also to make particles that help buffer the pH more by releasing stuff. It's also and you can also release certain payloads based on pH, which might be antibiotics, because infections tend to increase. Infections or inflammation actually increases pH, or changes the environment or lowers the oxygen, so you can increase like drugs and stuff delivered depending on inflammation and stuff like that. More locally to the brain. And all these things, particles are very hard to transfer over the blood-brain barrier, but if you have it in this device, you can do it much better, and you can replenish them faster. So, and also if you want to have it ultra-local, you could have the tubes deliver it local and this, and also you already confine more to the brain, because you're not having these nanoparticles flow around the whole body, and they could pass through the blood-brain barrier. And then you don't have to worry about it being a one-way trip. So you have all those different things I just started talking about. Now, another idea with this whole thing is that you could also use this blood-brain barrier one. I want to say it's not exclusive to the brain. Your spine has very similar conditions and also has it's part of the blood-brain barrier. Before you hit the brain, there's actually more additional filters. So the spine is kind of like, has its own buffer, then the brain has a buffer on top of that. So this could help healing spinal injuries. And you could also have it smartly redirect between the spine and brain depending on what needs more healing at the time. You could also use this to collect, if you not only having built-in sensors now I think about it, but also collect samples from the brain or spine better of fluids for more sophisticated monitoring. But safely. Now, the more you interact with the outside world, you run the risk hugely up of gaining infections or other things going wrong. That's why I said about genetically engineered bacteria or something that's specifically designed for this, because then it's a one-time thing and they can produce drugs or whatever. But they can't produce everything because that's just too complicated, especially like fancy stuff like PET or fluorofluorocarbons for oxygen delivery. So that's not always an option. And it's not always a good idea either. So sometimes you're going to have to put in stuff, and the way to make this maybe, so first of all, to open up, there probably should be a lot of locks, so it should be placed inside the body for safety. So inside or outside the body for easy access, but a lot of locks and stuff. Then there should be an easy sanitizable surface, which you can have special non-stick surfaces, special ones they can irradiate with microwave radiation and something called cold plasma, which is plasma that some of its plasma and electrons are moving at high temperatures. So electrons, but the atoms are not that moving that fast or something. So it's actually cold, but it's very good at killing off germs and stuff like that. And you can use a couple of washes, like an alcohol wash, supercritical CO2 wash even, which is a strange state of CO2 that is between solid, liquid, and gas, or some mixture of those ones. To clean off, they can't normally do it. Then you could put a needle in to inject it that's hyper-sanitized, or draw it out with a covering that slowly slips off as he pours it into the whole thing. So nothing ever touches it that isn't completely sanitized and touched by humans. And then I think you could even make it safe that average Joe could do it, and people could do it at home mostly, which is important if someone needs to have a lot of daily treatments because of an injury or something, or the ease or something like that, and can't make it to the hospital all the time. Accessibility really is key for most stuff to make it effective. I mean, disabled people are already the people that have the most accessibility options, least accessible, so, yeah. Now, again, if it's outside the body, we have also some other issues that I want to talk about briefly, is that if it's outside, it might look ugly to people. So you have to figure out how to make it look less ugly noticeable. If you plant inside of people, it's a more extensive surgery, which runs its own risk, and if someone already has brain problems, that is extra risky. But maybe you could combine it with other surgery, but then removing it if something bad happens might be extra risky. So a lot of pros and cons, you have to do it. Another thing that could make this device a little better while I'm at it is maybe combining it with how would I say it? If we combine it with other artificial organs, like if this is combined with an artificial heart and lung, then the transplant becomes even more doable, or doing this, because it can be all one device. And it could also take off work from the lungs and heart, so they could repair in an extensive thing. So maybe you could also help combine it with the bladder, because this is part of the urinary system. So that would be an interesting idea, to have try to make an artificial organ that takes as much of workload off the body as possible. Even though what I'm saying is kind of in many ways outlandish at this point, but I think it's something really to research, and the little steps forward might be big helps for many people, actually. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. With your help, I think I can do it. Also, if any of these for future videos, comments, or suggestions, please leave in the comment section below. Again, thank you very much. Goodbye.